All right, guys, so I'll pick up where we left off in class, which was checking to see if this rule was correct. Also, go ahead and see if you applied this and plotted it correctly as well, if you need to pause or slow down the video on your own at home. Okay, then we were talking about this question, right? Does this figure have rotational symmetry? So if we want to talk about the rotational symmetry, if this point were to rotate to this location, it would map on top of itself. If this point were to rotate to that location, it would map on top of itself, so on and so forth, right? So full rotation is 360 degrees. If we can turn this 5 different times, 360 divided by 5 means every 72 degrees that we turn or that we rotate, this is essentially mapping onto that next point. Okay, then if we want to talk about the reflectional symmetry, as I drew in a line of reflection, I went ahead and labeled it on both ends. That way I don't double count my lines, but it looks like in this case there are 5 lines of symmetry. Okay, then let's review what an isometry is. It's a transformation that preserves both size and the shape. Essentially, it's creating congruent, a congruent pre-image and image. Right, so we know that reflections, rotations, and translations are all isometries. One more rotational symmetry question. Looks like if this one moves to here, it'll map on, so on and so forth. So if you count all the way around, there's 6 different turns we could take. So 360 divided by 6 means every 60 degrees that flag is going to map onto the next flag. These are actually not going to have any line symmetry, so no line symmetry for that picture. All right, then we can talk about the questions on the back. Let me get a blank copy to write on. I noticed a problem with this one. This one has a single transformation or a single prime symbol. So what I'm going to do just to change this question is get rid of the second thing that happened. Okay, so point A is mapped onto A prime after that translation occurred. What are the coordinates of A? So remember, guys, if we are working backwards, we actually need to do the opposite of the operation that we see in that rule. Okay, so A prime is at -1, 4. So moving in the backwards direction, we need to actually add 4 to the x coordinate, making that 3. And then we need to subtract 1 from this coordinate, making that 3 as well. Okay, so what I like to do is work forwards once I'm done. If I take this, subtract 4, I get -1. If I take this, add 1, I get 4. So looks like that question is done. All right. Let's take a look at the next one. Point B is reflected over the x-axis. So point B, we take its original coordinates. We reflect it over the x-axis, which is going to, let's see, negate the y. Then we're reflecting over the y-axis, which would negate the x. Okay, so that's putting us at B double prime. Oops, I guess I could have filled in my labels. Okay. And now we have to think, what single transformation would map, okay, B double prime back to B single prime? Okay, so we got here in 2 transformations, but now we actually want to get back to the start in just 1 transformation. Well, it looks like in order to get back to the start, we need to change this sign, we need to change this sign. Okay, well, let's think about what transformation causes both the x and the y to negate at the same time. Okay, that's going to be a 180-degree rotation. About 0, 0, or the origin. Okay. Let's move to the next one. I've given us some blank space to work in. We're going to describe the transformation or transformations that occurred. Then we're going to write a rule to fit this description. So it says there's multiple correct descriptions, but only one correct rule. So let's go ahead and just take one step at a time, and we'll see what this looks like, and then we'll consider other possible answers or descriptions. So here's the deal. We can see that this is, well, I'm going to go ahead and add the symbols to it, but this will be B prime, this is going to be A prime, and that'll be C prime. So we can see that this thing has either, well, if I think about reflecting, if I reflect A and C are going to be on the wrong side, right? So I'm actually thinking that this is more of a rotation that's occurring. And if I think about just turning my paper, if I want to get this to look like this, okay, if I do it 90 degrees, not quite there. All right, if I do it 2 turns, which is 180 degrees, it looks like A is on the left, C is on the right, which is what I was wanting. So let's start with listing our original coordinates, or for our pre-image. 3, 4, 1, 2, -5, 4. Okay, so we're going to rotate 180 degrees. I'm going to rotate 180 degrees about the origin in this case. So if I rotate 180 degrees about the origin, that's just changing the signs. Okay, let's plot those and see where we're at. -3, -4, -1, -2, 5, -4. All right, we'll take a look at this. When I rotated that 180 degrees, okay, A is on the left, C is on the right, it looks like the only thing we have left to do is to translate. Okay, looking at that vector, we would go back 1, 2, 3, 4, so -4, and down 2, be a -2. All right, so let's see what happens when I do this translation. Minus, that's going to be -7, -6, -5, -4, 1, -6. All right, and if you look over here and check, A is at -7, -6. Okay, B is at -5, -4. C is at 1, -6. All right, so it looks like this worked. What we're going to do is, now that we've come up with our description, right, we have a rotation of 180 degrees about the origin, and then we translate left 4 and down 2. It also says to write the rule. Okay, so x comma y goes to, we did -x, -y, and then that would be -x minus 4, comma, -y minus 2. All right, so there is that rule. Now again, there's other possible descriptions, but regardless of the description that you pick, you should end up with the exact same rule once you simplify. So for example, if you rotate around something other than 0, 0, that's going to work, but your translation will be different, okay? And at the very end, your rule is still going to simplify to the same rule that you see right here, okay? So I encourage you to see if you can find a different rotation and translation that